Okay, physics. This is a video, and it's only about parallel circuits. Here's a parallel circuit. This bulb and these two bulbs are in parallel with each other, okay? Now, the first part of this video is me solving the problem. The second part of this video is me asking you questions, okay? So here we go. Number one, what is the current right here? Okay, now, how would I solve that? I would say V is equal to IR, and this is a circuit right here lighting this bulb, okay? So 120 volts is equal to some current times 200 ohms of resistance. So it will be 120 divided by 200 will give us our I. 120 divided by 200 gives us 0.6 amps. So 0.6 amps. Now right here is a different circuit that also has access to the voltage, okay? Now if I wanted to know the current right here or right here, it would be the same because this circuit, all right? We know that we add up the resistors. So to find the current here or here, we would say V equals IR. Okay, 120 volts is equal to, the resistance is 300 plus 300, so I times 600. To solve this, 120 divided by 600, all right? 120 divided by 600, 0.2 amps. So 0.2 amps are going through this part of the circuit, and 0.6 amps are going through this part of the circuit. They're both going through the circuit here. So the 0.2 amps and the 0.6 amps flow through there for 0.8 amps. Now I could ask you, what is the total resistance of the circuit? And you'd be like, okay, well, I know there's 120 volts total, and I know that the total amperage is 0.8 amps, so the total resistance must be 120 divided by 0.8, okay? 120 divided by 0.8. The total resistance is 150 ohms, and that's true. Now you may say, well, Mr. Perkins, if you have a 200 here and 600 up here, how can the total be less? Because electrons are flowing through both. So the battery is giving out amperage more than it would through there and there. So it's there and there together. So the resistance, the total resistance, is actually lower than the two separate groups of resistors. Now here is a formula for solving for the resistance of a parallel circuit, okay? I'm going to draw a parallel circuit, and the voltage doesn't matter. And we've got a bulb here. I'm going to call it 300 ohms. And we've got a bulb here. I'm going to call it 400 ohm resistor. And we've got a bulb here, I'm going to call it a 200 ohm resistor. And I could say, what is the total resistance? And you wouldn't be able to do it the way I did this problem because I'm not giving you the voltage, right? So therefore you can't find the amperage and you can't find the total amps. So how would you solve this problem? Well, there's a formula. The resistance total works like this. Resistance total, 1 over RT equals 1 over R1 plus 1 over R2, etc. Okay? How would we solve this problem? Well, it'd be easy with a calculator. We would say, I'll work it over here so you can see it. 1 over R total is equal to 1 over 300 plus 1 over 400 ohms plus 1 over 200 ohms. And using your calculator, you don't have to worry about fractions. Let's do 1 over 300. 1 divided by 300 equals 0.0033, 0.00333 plus 1 over 400. 1 divided by 400 equals 0.0025 plus 1 over 200 equals 0.005. So 1 over RT equals these. Let's add them all up. 0.005 plus 0.0025 plus 0.00, and this is 3333333, right? It just really, these threes really go on forever. Okay, equals 0.0108, right? Now, if 1 over RT equals this, then we can switch these two, and 1 over 0.0108 equals RT. So 1 divided by 0.0108 equals 92.6. The total resistance would be 92.6 ohms. All right. Now, I'm going to ask you some questions like this in a row, and this is going to be your homework. Question number 1. Diagram number 1. Copy this diagram. This is 400 ohms, 800 ohms, and 600 ohm bulbs in parallel on a 240 volt circuit. I want you to tell me the current here, the current here, the current here, and the total, and the total current right there, okay? Current total. Diagram number 2 here is what is the total resistance in this circuit? What is the total ohms of this circuit? Copy this, show me the math, and solve it.